Welcome back again to my channel. I am Ariana G. Alulud from BS in Math 2A, studied at Kapalan College of Agriculture, Science and Technology. And for today's video, we will have again a video tutorial about linear programming, specifically on how to solve linear programming using graphical method. I hope you will enjoy watching this video and you will learn a lot.
Just like the day that I met you, the day I thought forever, said that you love me, but that'll last forever. It's cold outside.
Now, let's begin. To start with, it is essential to know first what is linear programming. Linear programming is an optimization technique for a linear objective function and a set of linear constraints. The goal of linear programming is to identify the values of the variables that maximize or minimize the objective function, which is defined by an objective function. Now, what is the use of linear programming? Linear programming is useful for many problems that require an optimization of resources. It could be applied to production, logistics, high-level business operation. Now, when to use linear programming? When the purpose of the problem is to maximize or minimize some value and the constraints of the problem are defined by a linear system of inequalities, linear programming can be used to solve it. Now, let's proceed to the linear programming using the graphical method. But first, what is the use of graphical method and linear programming? Graphical method of linear programming is used to solve problems by finding the highest or lowest point of intersection between the objective function line and the visible region on a graph. In solving linear programming, there are things to consider, and these are the variables, objective function, constraints, and the non-negativity constraints. Now, to solve linear programming graphically, we must follow these 7 simple steps. Step 1. Define constraints. Step 2. Define the objective function. Step 3. Plot the constraints on a graph paper. Step 4. Highlight the visible region on the graph. Step 5. Plot the objective function on the graph. Step 6. Find the optimum point. And last, the step 7, find the coordinates of the optimum point. For example, Bronson's Anli Siomai was on the lookout for stocks of siomai. Inside the Kapalong market, there are 2 meat shops that sell siomai, siomai X and siomai Y. Both of them sell the same flavor of siomai, which are the chicken and pork. Now, we are given the following table for the products. And this would be the table. For the stock of chicken, siomai X have 1, siomai Y have 1. For the stock of pork, siomai X have 3, and siomai Y have 1. For the cost of each siomai, siomai X costs 4, siomai Y costs 1. For the maximum daily need, Bronson's Anli Siomai needs 50 stock of chicken and 90 stock of pork. Now, question. How much of each meat shop should Bronson's Anli Siomai use daily to maximize the cost and at the same time to meet the maximum daily need? Now let's start in finding or solving the linear programming using the graphical method. First, we must identify the variables, which are the X and Y, where X is for siomai X and Y for siomai Y. And identify the cost function or the objective function, which is the maximize Z is equal to 4x plus y. Then maximize the cost function subject to the constraints. Identify the constraints, and these are the constraints. Chicken x plus y is less than or equal to 50. Pork 3x plus y is less than or equal to 90. And x and y is greater than or equal to 0. The non-negativity constraints, x is greater than or equal to 0 and y is greater than or equal to 0. Now, we must solve its constraints. for the chicken, x plus y is less than or equal to 50. In order for us to find out the coordinate points of the chicken, let x is equal to 0 and find the value of y. X plus y is less than or equal to 50. Substitute x as 0 plus y is less than or equal to 50. Then the y will be less than or equal to 50. And the coordinate point is 0, 50. Next, let y is equal to 0. X plus y is less than or equal to 50. X plus substitute y as 0 less than or equal to 50, and the x will be less than or equal to 50. Then the coordinate point is 50, 0. This would be the graph for the chicken constraint. Next, we must solve the constraints of pork. 3x plus y is less than or equal to 90. So let x is equal to 0. 3x plus y is less than or equal to 90. 3 substitute x as 0 plus y is less than or equal to 90. Since 3 times 0 is 0, so bring down y. Y will be less than or equal to 90. And the coordinate point is 0, 90. Next, let y is equal to 0. 3x plus y is less than or equal to 90. 3x plus substitute y as 0 is less than or equal to 90. Then 3x is less than or equal to 90. Divide both sides by 3. So x would be 90 divided by 3 is equal to less than or equal to 30. And the coordinate points is 30, 0. And this would be the graph for the pork constraint. For the next step, we must put them all together on the graph. And this would look like. As we can see, there is an intersection. The point 20, 30. Next step, highlight the feasible region. This would be the feasible region, the red shaded part. Next step, we must look for corner points in order for us to find the optimum point. We have point 0, 0. Next corner point, point 30, 0. Next, point 20, 30. Next, point 0, 50. Next step, find the optimum point by finding the equivalent value of each corner point through the objective function. The objective function is the maximized c is equal to 4x plus y. And this would be the table for the corner point and the corresponding value of c. So corner point, 0, 0. Just simply substitute the value of x and y using the objective function. 4, substitute x as 0 plus substitute 0 as y is equal to 0. For the next corner point, 30, 0. 4 times substitute x as 30 plus substitute y as 0 is equal to 120. Next corner point, 20, 30. 4 times substitute x as 20 plus substitute y as 30, it will be equal to 110. For the last corner point, 0, 50. 4 times substitute x as 0 plus substitute y as 50, and it would be equal to 50. So we have the optimum point, which have the maximum value, which is the point 30, 0, which equivalent to 120 maximum value. So therefore, the maximum cost of each meat shop is 120 at the point 30, 0.